Instructional time differentiation, the next step for the blended rotation in mathematics. Navigator Schools has had incredible success over the past 5 years. Despite having one of the highest language learning populations, Navigator has eliminated the achievement gap. As you can see, in ELA, Hollister Prep School, one of the Navigator schools, is one of the top performing schools in English language arts. They have made significant gains in mathematics as well, but there's still much to be done. Despite Navigator's success in closing the achievement gap between language learners and non-language learners, there is another problem at a micro level. The lowest performing 25% in mathematics are not closing the proficiency gap between themselves and their proficient counterparts. The graph you see is real data from a 4th grade math class, and it is representative of what most of our math tests look like. The red represents 26 students, students we should not and will not let fall through the cracks. But we only have so many minutes in our instructional day, so what could be done? Here's some key research discoveries that I found. Time does matter, but how much or little it matters depends greatly on the degree which it is devoted to appropriate instruction. Learning time is the portion of the engaged time where students are actively engaged themselves in the lesson. And finally, an index of 5 policies suggested by 40 years of qualitative case studies: frequent teacher feedback, data-driven instruction, high dosage tutoring, and as you can see, increased instructional time, and a relentless focus on academic achievement explains roughly half of the variation in school effectiveness. So, instructional time does matter. Our current math model at Navigator Schools, Blended Rotation 1.0. We currently have differentiated instruction with homogeneous groupings. Navigator's leveled groups allow teachers to slow down and scaffold for the struggling math students and extend learning for the advanced learners. 3 groups of 10 students rotate through a blended learning rotation daily, spending the same amount of time at all 3 stations. First, they go from the teacher direct instruction to the paraprofessional guided practice, and then to the blended learning computer station. Now, the data shows that this isn't a bad model. After all, Navigator is outperforming an average Californian school. But what about those 26 students in 4th grade? And that's just looking at one class. We can do better. Here's the proposed math model, Blended Rotation 2.0. Navigator Schools differentiates instructional time in math centers in grades 4 through 8 based on student need to help close that proficiency gap. Here's what the math block would look like. The whole class would benefit from a 10-minute direct instruction, and then all 30 students would do their computer program at the same time. This would free up the teacher to do intervention or extension with very small groups. Next, there would be 2 30-minute rotations, where the low group would rotate through the teacher center and the paraprofessional center on a daily basis. The medium group would spend most of the week at the teacher center and the paraprofessional center, but would have a couple opportunities to work independently as well. The high group would spend some time with the teacher and the paraprofessional, but the majority of the time they would be working at the independent center. This model gives more direct instruction minutes to the low students while allowing higher students to move through the content at their own pace. This self-directed path to proficiency would include flipped instruction, Khan Academy, collaborative projects, and practice for those high students. Here's a graph of 2 fourth grade math classes at Navigator schools. GPS was higher all year long until HPS teacher experimented with that time differentiation. As you can see, when the model changed, so did the data. Her class closed the gap. In conclusion, I propose this model shift for Navigator Schools Mathematics as a 2016-17 pilot. The next steps would be to propose this model to the math department leads, decide if this will be an organizational-wide commitment or a pilot selected in certain grades or specific schools, get teacher buy-in, create an implementation plan, and begin rollout in August 2016. Thank you for your time.